Our unit today comes from chapter 7, and we are going to be beginning a unit on exponents. Now, for your clarification and make sure we're all on the same page, this is the coefficient. This is the variable. And the 2 is the exponent. And I'll be referring to them as such throughout this discussion. Now, we are going to be talking about integer exponents. And that's a new world for us, because remember, the word integer refers to the number line counters. Which means those are going to be both positive and negative, but they're going to be positive and negative whole numbers. There are about 6 or 7 different exponent rules, and we're going to start today with the first one. And that is the negative exponent. And that is a number raised to the negative exponent. There are a couple things about this. We know in front of any variable, if there is not a number there, it's assumed to be a 1. The second thing we know is that any number over 1 is itself. 11 is equal to 11 over 1. 5 is equal to 5 over 1. Even the negative numbers are themselves if we put them over 1. With that in mind, this is the same thing, over 1. Anything is itself over 1. So, what is the rule? Well, the rule is this. A to the negative n is equal to 1 over, oh, I messed that up, 1 over a to the positive n. This is the rule. Now, what does that mean? What is the definition of all that? You are going to move the base and the exponent across the fraction bar. And change the charge of the exponent. you're going to change the charge of the exponent. So we're taking several concepts. Any number is itself over 1, and there is a 1 in front of any variable. That gives us a 1 in the numerator and in the denominator, so that when I move that base and exponent across the fraction bar, the denominator exists, and this 1 remains if there's nothing else there. So, some examples of this, of what's going on now. 7 to the negative 1 is equal to 1 times 7 to the negative 1. Does everybody agree with that? Anything times 1 is that thing. And of course it has a denominator. So as I move this base and exponent across the fraction bar, I'm going to change this negative charge to a positive charge. And this 1 that was already up here, but not very often written out, stays there. So the answer here is 1 over 7. (25 to the negative 2 power is equal to 25 to the negative 2 power over 1. So now I got a fraction bar. I can move this 25 to the denominator and square it. 1 is in the numerator. And then I got to get out my handy dandy calculator and square 25. 25 squared is 625. Make sure your final answer is simplified. Now that's what happens with numbers. What happens when they're letters or variables? Well, very simply, x to the negative 2 is the same thing as 1 times x to the negative 2 over 1. 1 times that thing or that thing over 1, it's the same thing. So now I'm going to be able to move x to the negative 2 across the fraction bar, change the charge. The 1 that's down there is a 1 times that. So I have 1 over x squared. So the next one is a start example. And that is because I have y to the negative 3, the negative exponents in the denominator. There is still a 1 down here. 1 times that y to the negative 3. If we go back up here and we review the rule, it says move the base and the exponent across the fraction bar and change the charge of the exponent. It doesn't say from numerator to denominator or denominator to numerator. It says move it across the fraction bar. It's like a magic door. When you go through or through that door, it's going to change the charge on the exponent. So this 1 is here. This 1 is here, and I'm going to move this y to the negative 3 over the fraction bar, and that exponent is going to change its charge. Now we know 1 times y cubed is y cubed, and y cubed over 1 is simply just y cubed. That is now simplified. Okay? We good there? Everybody caught up? All right. So, if I have x to the negative 2 over 7 to the negative 1, Again, we're saying to get rid of to write this with positive exponents, I'm going to move the base and the exponent across the fraction bar and change the charge of the exponent. So this becomes 7 to the first. Similarly, this is going to go across, the base and the exponent are going to go across the fraction bar, and I'm going to change the charge of the exponent. X to the negative 2, y to the negative 3, over z to the negative 5th is more of the same. Z to the negative 5 is going to move across the fraction bar, and I'm going to change the charge of the exponent. X to the negative 2 is going to move across the fraction bar, and I'm going to change the charge of the exponent. Y to the negative 3 is going to move across the fraction bar, and I'm going to change the charge of the exponent. Everything now has been written with positive exponents. Let's think here a minute. If I have x to the negative 2, y to the negative 4, over w squared z to the negative 5, I'm sorry, positive 5, is this equal to w to the negative 2, z to the negative 5, x squared, and y to the 4th? Did I move this? Did I change the sign? Change the charge? Did I move this? Did I change the charge? Did I move this? Yep, I moved it and I changed the charge. Did I move this and change the charge? That is the rule. Move it across the fraction bar and change the charge. So yes, these are equal. Yes, these are equal. Let's look at something else. X to the negative 2, y to the negative 4, w squared, y to the 5th. Is this equal? W squared, x squared, y to the 4th, z to the 5th. Is this equal? Both sides. Are they the same thing? X to the negative 2. Did I move it? Yes. Did I change the charge? Yes. Y to the negative 4. Did I move it? Did I change the charge? W squared. Did I move it? No, it's still in the denominator. So I didn't change the charge because I didn't move it. Y to the 5th. Well, if I write down the correct thing, what I meant to write, maybe it will be not so confusing, right? Let me make this a z. Now are they equal? Yes, this z to the 5th is down here as well. I moved these, so I changed the charge. I didn't move these, so I kept the charge. All right, last one. X to the negative 2, y to the negative 4, w squared, z to the 5th. Is that equal to are those two equal? Are those two equal? Now, think about this. Equal and finished are two different things. Technically, I should move this to make it a positive exponent, right? I have only moved this, but when I moved it, did I move it correctly? So I have done the work correctly. I'm not finished. I should move this to the denominator as well. So my point is, yes, they are equal. It's just not finished. Okay? All right, now, the next big thing is something I'm hoping you've heard of before in one of your previous math classes. And that is this: exponents. Act only on what is directly in front of them. Exponents act on what is directly in front of them. I have 7x to the negative 2. And I know 7x to the negative 2 is a number, and putting it over 1, it's still the same thing. Now, a key point of information here is that all numbers as coefficients have an exponent. And if they don't, it's an unwritten 1. If they don't have an exponent, it's an unwritten 1. So that means this 7 has a 1. And I will encourage you to put that in there, because it keeps us from making some mistakes. It makes me realize this negative 2 is going to act on this x and only this x. It is not going to act on the 7. So when it comes to moving things around, that 7 is going to stay there. The 1 is in the denominator, and this x, because the negative 2 acts on it, will be moved across the fraction bar, and that will be made positive. Now you can clean that up, or you can leave it just like it is. We know that many times we don't write this 1 in front of an x squared. You could leave it like this, or you could clean it up like that. Either way is great. (5x squared over y to the negative 3). Again, I will remind you that this has a 1, so therefore that stays there. There is a 1 in front of the y cubed, y to the negative 3, I should say. So 5x squared y cubed over 1. We need to simplify this. You cannot leave that 1 in the denominator, so this is 5x squared y cubed. Sometimes I will have a negative 1 on that exponent, and that's fine. We just follow the same rules. Move it across the fraction bar and change its charge. X squared is not moving, and neither is z to the fourth, because they're positive exponents. 4 to the negative 1 is going to move to the denominator with a positive 1, and y cubed, y to the negative 3, is going to move to the denominator and become y cubed. X cubed, y to the negative 4 over z to the negative 2. Again, there's a 1 in the numerator, 1 in the denominator if I need it. The x cubed has a positive exponent, and it's going to stay right there. Z to the negative 2 goes to the numerator. Y to the negative 4 goes to the denominator. Five x to the negative 2, y cubed, over 2z squared. Again, I will encourage you to put these ones in here. Write down the things that are not going to be moving. And then move what needs to be moved. X to the negative 2. Our next examples are kind of tricky. They're not hard, you haven't seen them. You'll use these very little in Algebra 1, but you'll use them extensively in Algebra 2. The first one the start example, x squared y to the fourth raised to the negative 3 power. Now we're going to go slow, and we're going to incorporate the things we already know. Number 1, there's a denominator. We haven't talked about it today. We've talked about the 1 being out in front of a y or a z, but we also know there's a 1 in front of a parenthesis if there's nothing written there, correct? The rule says move the base and the exponent across the fraction bar and change the charge of the exponent. The thing that the exponent acts on is called the base. So I know this 1 and this 1 are going to stay here, but this is going to move to the denominator, and this exponent is going to be positive. Another example of this, instead of a 1 in front, I have a 2. I have a number in front of the exponent, or in front of the parenthesis, and that exponent is a 1, correct? So I know there's also a denominator. This 2 is not moving because it's a positive exponent already. This base is being acted on by a negative 2. So all of that is going to move to the denominator, and this exponent is going to be a positive 2. The last one is a triple star, triple asterisk. It's a biggie. It's not hard. X squared over y cubed raised to the negative 2 power. Raised to the negative 2 power. Once we learn the other rules, this will make more sense. But right now, the memorization of this is this. I have a negative on the outside. Everything on the inside moves back and forth across the fraction bar and becomes positive. The inside flips, and the outside exponent becomes positive. The inside fraction flips, numerator to denominator, denominator to numerator, and the exponent becomes positive. Okay? We good there? You good? All right. So, now we're going to evaluate. Evaluate means to substitute for the variable and use PEMDAS. So we are going to evaluate 2x squared y to the negative 3 when x equals 4 and y equals 3. Before I do anything, I'm going to substitute in or put in that 1, and I'm going to put a denominator here, and I am going to rewrite using positive exponents. Rewrite using positive exponents, which means the 2 is going to stay in the numerator, the x squared is going to stay in the numerator, and the y is going to move across the fraction bar and become positive. The next thing I'm going to do is substitute using parentheses. The x is equal to 4, so I substitute a number for a letter. I always use parentheses. Substituting 3 for y, I use parentheses there. I am going to simplify using PEMDAS now. There's nothing inside those parentheses I can do. There are some exponents. I start with those. 4 squared is 16. 3 cubed is 27. And after that, I'm going to do the multiplication and division. that is going to give me 32 over 27. That's my final answer, because there is not a number that goes into both of those to reduce it. And we don't have mixed numbers in Algebra 2 or Algebra 1, either one. Rule number 2 is a power of 0. And the rule says any number raised to the 0 power is equal to 1. So if I have 3 to the 0 power, that's equal to 1. 99 to the 0 power is equal to 1. X raised to the 0 power is 1. Thank you. Theta raised to the 0 power is equal to 1. An apple raised to the 0 power is equal to 1. Anything you can think of raised to the 0 power is equal to 1. Two x to the 0, I'll remind you, means 2 times x to the 0. 2 times 1, pretty simple. Negative 2, x to the 0, y squared. Similarly means negative 2 times x to the 0 times y squared. Negative 2 is negative 2. X to the 0 is 1. And y squared. Doing the same simplification we did before, writing it with positive exponents. First, always do that first, and then deal with x to the 0. Y to the negative 2 is going to move to the denominator, and z to the negative 3 is going to move to the numerator. This is 4 times x to the 0 times z cubed. So it's 4 times 1 times z cubed, which is simply 4z cubed, over the denominator of y squared. Seven to the negative 2 x cubed. Remember, this is over 1. So you're going to move the 7 to the denominator and change the charge on the 2. X cubed stays right where it's at. And then you got to polish it up at the end and square that 7 to get 49. 2 to the negative 3, x to the negative 5, y to the negative 2. The first thing you do is write it using positive exponents, which means y squared goes to the top, 2 to the negative 3 goes to the denominator and changes its charge, x to the negative 5 goes to the denominator and changes its charge, and then you got to find out what 2 cubed is. That's 8. Write the others in there, and that's all you need.